Hi everyone, we're going to use the principle of mathematical induction to show that the given statement is true for all natural numbers. This one's a little different because it has these negatives here, and it equals negative, the sum is negative 1/2 n times n plus 3. So the first thing we're going to do is check for condition 1. That means when I plug in 1 into the sum here, it should equal negative 2. So we're going to check for n equals 1, so I'm going to plug that in. We have negative 1/2 times 1 times 4, 1 plus 3, so we get negative 1/2 times 4 equals negative 2, which does equal our first term. So that checks. And now we're going to check for condition 2. We're going to, if it works for some natural number k, then show that it works for the next term, k plus 1. So I'm going to copy down this first statement here just with k. So I'm going to rewrite it. It's minus dot 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 minus n plus 1 equals negative, oh, not n, but it should be what? K. So k plus 1 equals negative 1/2 k times k plus 3. All right, now I'm going to check for the next term, which is k plus 1. So I'm going to write negative 2 minus 3 minus 4 minus dot 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 minus k plus 1 minus the next term is going to be k plus 2, because you're just adding 1 to that. And this side is just going to be k plus 1. The next term is just going to be k plus 4. Now we want the right side to look like the left side. I'm going to use substitution. This piece here equals this piece, because it's right here. And so I'm going to write that down. This is negative 1/2 k times k plus 3 minus k plus 2. Okay? The first thing I'm going to do is pull out a negative 1/2. So I want it to look like that. When I pull out a negative 1/2, I'm going to get k times k plus 3, and I'm going to multiply this part by 2 so it can join in the group here, because this is one piece and this is another piece. So, and this is also going to change to positive 2 times k plus 2. So if you see what I did, when you factor out a negative 1/2, when I multiply negative 1/2 times 2, that gives you the negative 1 that was here. It's just an easy way to do that versus trying to get the common denominator every time. Now it's pretty simple from here. Simplify this quantity in here. You get k squared plus 3k plus 2k plus 4, which is negative 1/2 k squared plus 5k plus 4. And then we can either FOIL this piece out and make it look like the left side, or I'm going to go ahead and just factor this out and make it look like the right side. So this is going to be k plus 1 times k plus 4, which is what had to be proven. Condition 1 and condition 2 have been satisfied. Therefore, the given statement is true for all natural numbers n. Thank you and have a nice day. Bye-bye.